In this video, you will learn the basic techniques for examining the structure and contents of an Analytica model. After you watch this, you should perform the steps on your own by opening the tutorial from the Help menu and proceeding through Chapter 2 at your own pace. As in the previous lesson, we will use the rent versus buy model. First, double-click on the module node. The details of the Analytica model display as an influence diagram, which is a visual representation that shows how different variables in the model interact with each other. The nodes here represent variables, with the different shapes representing different types or classes of variables. In Analytica, we use the term variable broadly to include anything that has a value or can be evaluated. Many of the variables here have the same names as the inputs and outputs on the top-level diagram from the first lesson. The top-level diagram provides an easy way to see and change these variables' values. The arrows connecting different variables indicates a relation between the variables. For example, this arrow indicates that appreciation rate depends on rate of inflation. We see that cost to buy depends on the buying price, appreciation rate, rate of inflation, discount rate, and time horizon. A decision variable is represented by a rectangular node. This would be a variable that is directly under the control of the decision maker. A general variable is a rounded rectangle. Typically, they're used to represent a deterministic amount or a functional relationship. You can use this for any variable when you don't know what the type is. An oval denotes a chance variable. These are quantities that cannot be controlled by the decision maker and may need to be estimated. We use a probability distribution to represent the uncertainty in these values. A hexagon is an objective variable. This is the modeler's goal, and it evaluates the overall value or desirability of the possible outcomes. Here, our goal is to evaluate the cost difference between renting and buying. Decision models often contain a single objective node. The nodes with thick borders are module nodes, and these contain submodels of their own. Module nodes help keep each diagram simple and understandable at each level by encapsulating details within nested modules. Now, double-click on buying price to open its object window. We see that a variable is composed of a list of attributes. At the top left is the class. It's a decision variable here. The variable's identifier is price. This identifier is used in the definition of other variables. An identifier can contain up to 20 characters, no spaces. The title describes briefly what the variable represents, and the title text appears in the node on the influence diagram. The units attribute documents the units of measurement for the variable, dollars in this case. The description is the primary documentation attribute. It is not limited in length. The definition specifies the value, or it may contain an expression that tells how to compute the value using other variables as inputs. It may also be a probability distribution or any other mathematical expression. This definition uses the K suffix to denote thousands. This is equivalent to writing 140,000, but the suffix notation helps make very large or very small numbers easier to read. Other variables depend on buying price, shown here as outputs. For each output, the identifier and title are shown. Let's double-click on mortgage, which jumps to the object window. Once again, notice that mortgage loan amounts title is different from its identifier. The title is what the user of your model will usually see. The identifier is used as a mathematical symbol in the definition of other variables that depend on this one. The identifier always has to be globally unique. No matter where you use the identifier, it refers to this variable and this variable only. The definition of mortgage loan amount is an expression, the sum of buying price and down payment. Wait, why isn't this price minus down payment? Let's look at the down payment variable by double-clicking on it in the inputs field. The description says that down payment is negative, so that's why it isn't subtracted. In fact, this model consistently uses a common financial flow convention that funds flowing in or received have positive values, whereas funds flowing out or expended have negative values. Now notice how helpful that simple comment was for avoiding this potential confusion. I encourage you to use that description field liberally for these things in your own models. It makes a big difference for end users of your model. It'll help you avoid stupid mistakes yourself. Close the object window. You don't have to open a separate window to view the attributes of a variable. variable, you can also inspect them in the attribute panel at the bottom of an influence diagram. Click the key icon to open the attribute panel. Initially, it shows the description of the selected node, but from here you can inspect any attribute of a variable. Click on the attribute pull-down to change description to definition. The buying price is defined as 140K. Click on the rate of inflation node, and now we are seeing the definition of rate of inflation. It's defined as a normal distribution depicted as a button labeled normal with a mean of 3.5 and a standard deviation of 1.3. You might remember this one from the first lesson. Analytica models generally have modules. Each contains the detail of some part of the model. Here we have two module nodes, cost to buy and cost to rent. Double-click on cost to buy to open its influence diagram. Now we have three additional module nodes. Mortgage loan amount has a small little arrowhead coming into it on its left side. This indicates that it has one or more inputs from outside of this module. By clicking on it, we can see that its inputs are down payment and buying price. Present value of buying has one or more outputs that are outside of this module. We can select the output and jump to that object. You can also view inputs and outputs from the attribute panel. Let's select buying price and view its outputs. Notice that in the diagram, buying price has an arrow to cost to buy. Cost to buy is not an output of buying price. It's a module that contains one or more output variables of buying price. In the attribute panel, we can see what those outputs are. Double-click on insurance. This jumps to a diagram for a sub-module somewhere inside cost to buy. This module may be several levels deep, so to get an idea where you are in that module hierarchy, go to the preferences on the edit menu and turn on the show module hierarchy preference. Now we have a navigation strip along the top of each diagram window showing us the path from the top level to the current submodule. My personal preference is to always keep this on. When you hover over a variable node for about a second, a help balloon pops up with the variable's title, units, and description. These allow you to rapidly browse information about a model without having to open the object window. Help balloons do not appear when the object does not have a description or a help attribute filled in. We can jump to a module by clicking on the navigation stripe. Let's look at the computed value of present value of buying in the attribute panel. Select a node, open the attribute panel, and select the value attribute. Analytica computes this value by setting all uncertain inputs to their median value and then computes the result deterministically, which is to say without uncertainty. We refer to this as the mid value. You can click on other nodes to quickly view their mid values. It's faster to compute a deterministic mid value than an uncertain or probabilistic value, so it's useful for conducting initial checks before you perform uncertainty analysis. We can view the result of any variable in a result window by pressing the result button on the toolbar. This result shows the computed probability density graph for the variable. Close this window. You can alternatively select the result view from the result menu. This time, let's look at the cumulative probability graph. Press the diagram toolbar to jump to the parent diagram. Let's display the result for moving costs. Now a single mid-value number appears. Using the uncertainty view menu in the upper left corner, I'll try to view the probability mass for this variable. It tells us this value is not probabilistic. In this lesson, you've learned how to examine a model's influence diagrams, variables, attributes, definitions, and results. These are the basic techniques for exploring any Analytica model. In the next tutorial chapter and video, we will analyze the rent versus buy model.